Well, that's a Ryzen 1800X system behind me that's running this Crucial Ballistics Sport DDR4 2400. I mean, 2400, wait, I thought Ryzen was sensitive to memory speeds. Well, it is, and it is because the Infinity Fabric, but we've overclocked this RAM to DDR4 3200. How'd we do it? So the first thing that you have to understand is that when you see a memory speed like DDR4 3200 or DDR4 2667 or something like that, memory speed is not really the whole story. Really what you want is relatively low memory latency normally, meaning that the time it takes to get data in and out of memory is faster the better kit of memory that you have. And so sometimes you see it written as like 3600 mega transfers per second because with DDR4 it's double data rate, and then you end up with like a clock speed that's like half, but it transfers twice depending on what you're doing, and RAM's complicated, sort of, kind of. But the only thing that you really need to know is the cast timing. So if we look at this is 2400, 16, 16, 16, 39 at 1.2 volts. Okay, so what's the deal? How are we going to overclock 2400 memory to 3200 memory? Well, we're not actually really going to make the memory any faster. If you check out this article on Crucial.com, you can see that the actual memory latency has basically flatlined, even though memory frequency is increasing, unless you get really expensive memory kits that have a really high frequency and really low numbers for the timing. Because you can actually be in a situation where a DDR4 2400 kit is actually faster than a 2667 kit is faster than a 2933 kit, depending on the memory speed and the actual timings. Now with Ryzen, the platform, the Infinity Fabric, the thing that's used to connect the two compute complexes together, Ryzen is really two 4-core CPUs on one chip, basically. The thing that communicates with that is called the Infinity Fabric, and it's tied in with the memory speed. The Infinity Fabric runs at half memory speed. So if you can get the clock speed of the memory higher, you'll benefit by actually increasing the inter-CPU communication speed. And so if we look at things like the gaming benchmarks where the 7700K is pulling ahead of Ryzen, if you are able to overclock your Ryzen CPU to be able to operate with DDR4 3200 memory, even though technically it's not really going to operate as fast as a true DDR4 3200 memory kit in a lot of cases, you can actually see a performance benefit from that. And so we've got the inexpensive Crucial Ballistics memory, and we're actually going to run it at DDR4 3200. Now, how do we actually do this? Well, math saves the day again. DDR4 2400 running at a 2400 speed. If everything happened in one clock tick, we would be talking about 0.83 nanoseconds in order for this thing to get something done. But because we know that the latencies for certain operations is 16 cycles, we multiply that by 16, and we get about 14, not quite, a little less, nanoseconds for this kit of memory to do something. So if we increase the memory speed to say 2666, we've gone from 0.83 nanoseconds to do something to 0.75 nanoseconds to do something. We need to increase the latency numbers so that it's still roughly the same amount of wall clock time, meaning that roughly the same amount of time passes because we're not actually going to make the kit of memory faster, we're just telling the system to wait on it longer. But because of the relationship between the Infinity Fabric and the RAM, it actually will realize a small benefit in programs like Cinebench and also in certain kinds of gaming benchmarks where inter-core communication is important for the results of the benchmark, for the results of the thing. I think actually you're going to see a lot more testing and retesting as Ryzen kind of stabilizes over the next few months, where faster clocked memories are going to bring it much more in line with the 7700K in terms of gaming benchmarks. And of course, nobody really argues that all of the other benchmarks are basically with Ryzen in the lead at a significantly lower cost, or Ryzen at least at parity at a significant lower cost for the equivalent Intel parts. So hey, competition's good no matter which way you swing. Now, if the math for this is a little too tricky, I've put together a little spreadsheet on the Level 1 Tech's website. So there's a link to that in the description of this video. Maybe we can get the annotations right. There's like an annotation thing that we can do, but they kind of turned off annotations. Cards, I guess is what they're called now. Maybe we can do a card that links to the website so that you can plug in your memory speed and your desired memory speed and actually get it to go. Now with this ballistics kit, I actually had a little trouble. The math works out to some numbers that don't actually work in reality. And so if you run up against that, you can just increase the numbers a little bit until you get stability. I'd also recommend running a memory test overnight, something with like AIDA64 or memtest86 overnight, just to make sure that your memory is stable, because if your memory is not stable, your system is not going to be stable. Now, I've actually got 5 or 6 kits of this ballistics memory for a project that I'm working on. Probably won't do a video on that, it's just sort of a project that I have. But most of the kits will hit 2933 no problem. I would recommend increasing the voltage from 1.2 volts to 1.35 volts. A lot of DDR4 is designed to really operate at 1.35 volts anyway at a higher frequency. 1.2 volts is more sort of a modern platform. If you try it at 1.2 volts and it's stable, you know, that's fine, it's gonna produce less heat. But for me, for these kinds of kits of memory, 1.35 volts. So, works out. So let's take a quick look at our before and after Cinebench benchmarks. Now, we can see here that there's not really a lot of difference between the two, but if you're looking for better numbers in gaming, especially 1080p gaming, low frame rate gaming, the increased speed will help you. Now let's talk for a second about things that the AMD platform officially supports. Now officially, if you're gonna run double-sided memory, that means dual rank memory typically, that's a lot of the 16 gigabyte sticks of memory that are out now. So if you've got 4 16 gig sticks, 64 gigs of RAM, at least at the time of this video, that means you're gonna be running a dual ranked configuration, and with 4 DIMMs, that's sort of a worst case scenario. The advertised speed from AMD right now is 1866, which is pretty pokey. If you're gonna run 4 8 gig sticks, that's also not an ideal situation. 2 8 gig sticks as of right now with the Samsung B die is just the memory that Ryzen likes best, or that has been most qualified. This is mostly down to software though, because different software updates, different UEFI updates are gonna bring better compatibility. We're doing this video on a Gigabyte Aorus Gaming 5. The first few versions of the UEFI, you know, I couldn't get stability past 2933, and even 2933 was a little sketchy. But by the time you've got BIOS F5F, memory compatibility has improved dramatically. So I think that trend is going to continue with Ryzen. Now these are overclock speeds, just like on the Intel platform. You know, officially Intel only supports DDR4 2400 on Kaby Lake. So, you know, you might theoretically get a chip or a board or something that doesn't support the higher speeds. Technically you are overclocking, and technically you are still overclocking the 2400 memory to run at, you know, 2933 or 3200, because it's not really designed for that. So you might conceivably get a kit that just won't overclock, or just, you know, won't work. About 3/4 of the kits that I had of the ballistics memory would go to 3200, but with really insane timings, like 25, 25, 25, like 50, or something like that. And it does actually help a little bit with certain types of benchmarks. Now, if you open the timings up too much, you'll actually make performance worse, because it would be better to just deal with the slower Infinity Fabric. We could see a future UEFI update or something like that from AMD that will actually resolve this problem. But for now, this is how you can squeeze more clock cycles, but not actually really more performance out of your memory on AMD Ryzen, and maybe get a little bit better in benchmarks. For me personally, the best that I've been able to do on the Aorus is DDR4 3600, but that was with a 112 megahertz FSB, because it won't actually let you set more than 32 in the UEFI as of this video. But the amazing thing with that is that that was with actually a DDR4 3200 kit, just with the timings increased. Incidentally, that's the same kit of memory that we used for the Firestrike record. We got kind of it's not really a big deal, but we kind of got a really high score on Firestrike for a Ryzen system. There's a separate article about that on the website. So there you have it. If you have Ryzen and you happen to have a DDR4 2400 memory kit, you don't necessarily need to throw it out in order to get faster memory speeds. There's an option for you. You can play with those settings in your UEFI and maybe take up the speed of the platform a little bit. Give it a try and let us know what your settings are. Post your kit of memory, like the part number and the timings that you were able to achieve and what motherboards you have on the Level 1 Techs forums, and then everybody can benefit from your experience. And that would be really great. I'd really appreciate it. That's where I'm gonna go hang out, in the Level 1 Techs forums. Hopefully this has been a quick and informative video. Good luck and happy hunting for memory timings on your Ryzen platform. I'm Wendell, I'll see you later. It's Twitter. It's Twitter. The tweet matrix.